A closed cylindrical can is to contain a volume of 6,400 pi centimeters cubed. Find the dimensions of the can that minimizes the area of metal to be used in its construction and state the area. So let's start with a diagram of the can. So let's let the radius here be r and the height h. Then the volume is pi r squared h. But we know the volume. So 6,400 pi is equal to pi r squared h. Pi's cancel, and I'm going to rewrite that as h is equal to 6,400 over r squared, and that will probably become apparent why I've done that in a moment. Now we're interested in minimizing the area, so that's going to be the surface area. The cylindrical can is made up of two circles, each of which has an area of pi r squared, and then the curved surface, which for a cylinder is 2 pi r h. Now, we had this relationship between h and r here, so that's going to be 2 pi r, 6,400 divided by r squared. So tidying that, we get, so that will cancel with that one, and 2 times 6,400 is 12,800, and that's going to be r to the power -1. So ds dr, that's going to be 4 pi r minus 12,800 pi r to the -2. And we want ds dr equal to 0. So that means that 4 pi r would be equal to 12,800 pi over r squared. Pi's cancel. And so r cubed would be equal to 12,800 divided by 4. So 12,800 divided by 4. I've actually got there in my head before I actually did it on the calculator, but never mind. And so r is going to be the cube root of that. So last answer to the power 1/3 is as good a way of any as doing that. And that would give me 14.736 and so on. So we'll say that's 14.74 centimeters, correct to 2 decimal places. So we can now find h from here. So we're going to have 6,400 divided by the last answer squared. So that would make that 29.47. Correct to 2dp. And then we want the actual surface area. So we could use this one here. So we'll have 2 times pi times this one squared. Actually, I'm going to go for the original 2 pi r squared plus 2 pi r h plus 2 times pi times this one, and multiply that by this one, and that gives us 4093.25 square centimeters. Correct to 2 dp.